All right, good morning. Forum 360, thank you so much for attending this morning. I'm joined with my Lockheed cohorts here, colleagues, Dan Lorden, Adam Breed, and Mike Baylor. And we're gonna talk to you about the AI Fight Club, Artificial Intelligence Fight Club. And so what's the first rule about Fight Club? We don't talk about Fight Club, right? That's the first rule, but we're gonna break some rules because you gotta break some rules to innovate. And so I'm Linda O'Brien. I'm the chief engineer for Lockheed Martin Aeronautics. I have the great fortune of leading a team of chief engineers who make sure F-35, F-22, F-16, C-130, U-2, and some things we can't talk about are safe, airworthy, and meet our customers' expectations. It's a great privilege. And so I'm going to go down the row here, and everybody's going to introduce themselves, and then we'll get started talking about Fight Club. Dan?
Thanks, Linda. I appreciate it. Good morning, everyone. My name's Dan Lorden. I'm the Senior Manager for Mission Operations in our Applied AI team at the Lockheed Martin AI Center. It's a bit of a mouthful, but I manage a team. I have the privilege of managing a team that develops products and solutions that help proliferate AI across Lockheed Martin. Everything from core AI building blocks through to frameworks and tools for interoperability across systems, and then core platforms for simulation and visualization to test AI, which obviously AI Fight Club is a major piece of that.
Yeah. Hi, Adam Breed. I'm the Chief of Innovation for our Training, Logistics, and Simulation line of business that's located here in Orlando, Florida. My main responsibilities are on our strategic approach for our research and development efforts and partnerships, both internal and external, to use that simulation and training technology to make us better, cheaper, faster.
Great. Hello, I'm Mike Baylor. I'm the Chief Digital and AI Officer for Lockheed Martin. I'm responsible for the overall AI strategy for the corporation, the technology, infrastructure, process for the development and application and scaling of AI across the corporation. I lead a team of about 350 professionals called the Lockheed Martin AI Center, or LAKE, to which a lot of this stems from that you're gonna see today.
All right, thanks, Mike. Mike, I'm going to start with you for this first question. So we have a lot of the home team in here, I see in the room, but for the folks who don't really know what AI Fight Club is, can you talk to us about this environment?
Yeah, it's a good question. I'll start with the overall Lockheed strategy and kind of walk down into the AI Fight Club. So Lockheed, from our CEO down, we have a strategy called 21st Century Security. And it's about building advanced, interoperable and resilient solutions for our customers so we can move faster and ultimately build cheaper systems for our customers. One of the tenets within that is to partner with industry and the best of what's out there commercially, and really bring together a defense industrial base. From an AI perspective, going to the AI strategy, we've been investing in AI significantly for really decades, but in the last 5 years, we created a corporate big bet for our overall AI strategy, which we formulated the LAKE, build out the infrastructure and technology to scale AI across the corporation. We have over 80,000 engineers leveraging generative AI across the company. We recently built a no-code assistant builder for the company and released it last March. And we have over 20,000 assistants that we built across the company. And it's not just my organization, it's meant to scale across all Lockheed Martin employees. Everyone has access to these things. So we've been doing a lot from an AI perspective. But one of the things that we realized is obviously we're doing pretty well from an AI perspective. We're happy with where we're at currently. National defense is a team sport. We realize that. We need to bring the best of industry together with us to be able to provide most effective solutions for our customers. And with that, the simulation and test and all of that is going to be very important. Hegseth just put out a AI acceleration strategy yesterday, I think it was. It has warfighting, it has intelligence, and then it has an enterprise, the solution to it. And within that, if you unpack that, one of the warfighting capabilities is there's a need for advanced simulation to test these AI capabilities out. And we see that in spades. A lot of times AI is treated as a black box, I guess, putting on programs. You can train that black box to do exactly what you want it to do, but what we're seeing is the second and third order effects of other systems interacting with that AI is where you can run into trouble. So to have a high fidelity simulated environment to be able to do that is key, which is what we're going to talk about, these gentlemen are going to talk about today with AI Fight Club and the Pearl infrastructure that we have to host the simulation, the infrastructure, all the connectivity or whatnot. But last year, I think it was March-ish or April, at SESP, we announced the AI Fight Club. And it's really to bring in the best of industry out there. Small businesses, large businesses, academia. I offer to anyone in this room, if you're interested, go to our website and sign up. We will reach out to you or pull us aside after we chat. We'll get connected. But we want to bring folks in. Put your pride aside and let's take AI against AI. They're going to talk about some really cool use cases that I totally want to talk about right now, but I'm not going to steal their thunder. Really compelling simulation that I think without this, given the complexity of AI in general and the complexity of these things being embedded within systems and systems, is going to be critically important. So we get various organizations together, get our AI, and we learn from each other. Steel sharpens steel is the tagline we like to use. We're learning a lot from this, and I think it's a big part of the future for AI.
Yeah, I love the thought of this being more kind of consortium-minded, where we're learning from each other, because I think that's what's necessary to move the needle in the way that we do for the nation. Adam, I'm going to direct this next question to you. So we've had simulation environments before. What's new about this? What gaps are we actually closing with the tools that the simulation environment that we're putting together here at Lockheed?
Yeah, I think with the Pearl system we're building in support of AI Fight Club, it is really focused on leveraging a lot of the key discriminators that Lockheed has previously built for simulation and training use cases. Lockheed has been running simulation and training programs for multiple decades, and we leverage a lot of that tech to build the foundation of Fight Club. And the reason behind that is there's a major urgency to get to this capability. Craig talked a lot about, earlier in the opening session, about there's not a great way to evaluate a lot of these AI systems, especially with second and third order magnitudes. We are very experienced in building things like digital twin and digital twin related things that are focused on the specific platform, for instance. But we aren't in necessarily the joint all domain experience, where we're talking global scale AI use across many different platforms, some made by Lockheed, some not made by Lockheed. And we need to integrate all of those together, but you still need this natural living environment, and you need all of the interfaces and capabilities to make those AI agents unaware they're in a simulation. Why? Because these simulations are going to be the first time the AI sees something, potentially before it's actually deployed. That's really a goal of AI Fight Club, is to create that environment, both synthetic and not, but to be ready for when it's deployed to the real world. So you got to make it real as possible. The simulations are higher fidelity than they've ever been before. Thanks a lot to some partnerships we've done. We're leveraging a lot of commercial tech to pull this off, but Lockheed's key discriminators is what we've been good at in the past, and that's modeling and sim. And we have an extensive library of capabilities that we're leveraging to pull this off.
Adam made a great point there. It's an extensive library. A couple of things for point of clarity. Both Mike and Adam here use the acronym PEARL. PEARL stands for Persistent Environment for AI Readiness and Learning. There's a major investment that we're making in Lockheed Martin, as both of them said, in simulation and visualization. AI Fight Club, as we'll talk about it for the next 50 minutes or so, is a proving ground, and it's meant to be utilized within the overall Pearl effort, where we are bringing in industry, academia, and really kind of some competitors to be able to have that open environment to compete, to test each other out, to make sure that we understand what our weaknesses are, what our strengths are, and how we can work together across industry, utilizing these events that we're planning out. And so, I'm not going to necessarily repeat what Adam said, but that's what Pearl is meant to do. We do have some partnerships under an effort that we call Astris AI for Government that are being leveraged to help bring Pearl to the industry as well.
Okay. And I'm glad you defined the acronym. I'm going to define another one that we use indiscriminately, which is the word LAIC. But it's really LAIC, and it's the Lockheed Martin
AI.
Artificial Intelligence Center, LAIC, LAIC. Okay, and actually, Dan, I want you to go a little bit more into why is this environment where it's safe to fail, why is that critical before we introduce anything into an operational environment?
I think one of the great things that you see, especially when discussing artificial intelligence, is just the absolute magnitude and impact that it has across our systems and society, is that trust, verification, validation are paramount to be able to adopt AI at scale. Where simulation visualization comes in is that it allows us to run just an inordinate amount of scenarios to be able to really kind of see how these agents, how these systems work in the emergent space. Adam sent us a couple stats just the other day. One of the first scenarios that we're working on with AI Fight Club is a 4v4 air combat scenario. And just what he told us here, and I'm going to get it wrong possibly, so correct me, is that just 1 month of training of these these teams of agents, identifies, I think, what you'll call just the kind of events and the end result of the scenario over 18 million times. And I mean, that's just absolutely astounding. In addition to that, if you were to kind of consider the resultant cost of those platforms, it's over $550 trillion. It's just astounding that over just about a month of training of these systems can have that level of impact to really kind of explore that emergent space. And so I think that's really just the beauty of what we're looking to accomplish here, both with Pearl across all of the business areas and all the areas that we work from a technology development perspective, but then obviously specifically with AI Fight Club and the scenarios that we're exploring.
Yeah, I think it's kind of a little bit of an obnoxious kind of metric that I put out there, but you can blame me for it. But it would have taken, if we didn't have these synthetic environments, it would have taken over 114 years, upwards of $500 trillion, 18 million fourth-gen fighters destroyed. Like, you have to have this synthetic environment to not only train, which those were the training numbers, but to then evaluate and test these models. You can see the data stack that was brought up earlier. Rich data, right data, good data is key to all of this story for all of us developing AI. When you look at the data pyramid, one was made famous by NVIDIA, where you have kind of the web data, the public data on the bottom, and at the top you have real world data. That does not work for many, many, many defense use cases. So you've got that middle section of the pyramid. The only way to pull it off is synthetic data. So that's synthetic data to train and synthetic data to test and verify. We're trying to hit both of those with Fight Club, but if somebody has tested their model, if somebody has trained their model completely independently, this should be a great use case to test it in that second and third degree method. It's really powerful. It's going to be really extensive to where it goes, starting with 4v4. I think the key to the 4v4 story, and Dan and I have talked this a lot privately, is we really wanted to make the first Fight Club simple as possible. You could argue 4v4 might not be as simple as possible, but it's simple as possible with a real defense-focused use case. That's a big key piece, is we want this to quickly translate to operational deployment, or at least test that it's going to be ready for operational deployment.
Yeah, I think you actually touched on something really good, is that the kind of how we use Pearl and how we approach everything we're doing from simulation as visualization is it's not just running a specific scenario and understanding how the agents perform. We use it for operations analysis or mission analysis.
I was going to ask you,
right?
are the OA folks involved?
I mean, that's exceptional. Kind of another anecdote is when we're hosting some of these wargaming style events, it can take months to plan, to set up, to integrate all of the different systems that we're testing out or looking to analyze in those events. With simulation, with Pearl, we want to be running those really kind of on a daily and weekly basis. And just think about how much you learn when you're running these on a daily, weekly basis. You're training your AI agents to kind of react and perform relative to understanding those performance parameters, and then tying it right back into the way that you're going to analyze it next week. And so from, as I was saying up front, from a verification perspective, that is something that really just kind of, this type of technology, this tech stack, really makes just a humongous difference.
Oh, that's awesome. So I have a question, and Adam, let's see, maybe it's Mike. Mike, I'm going to give you this question too. So there's been a lot of movement, innovation in commercial modeling and sim tools. Where can we leverage that in the defense industry? And then where is it appropriate to deviate from the commercial environment?
Yeah, it's a great question. We realize, again, national defense is a team sport to include, defense industrial base partners, but as well as, commercial. We're already doing it, which is great, right? You have companies like Meta that we're partnering with that does a lot in this area. NVIDIA, obviously, think of NVIDIA with GPUs, but they do a lot in this area from a simulation perspective as well. You look at, my kid logs into a, video game and they spawn, it takes, 5 seconds. A lot of, what I've been doing for the last 26 years is, wargaming exercises where we might meet once or twice a year. What if we could have that environment more persistent where it's easier to get in? So that's a lot of what the commercial learnings is going to drive into what we're doing here. But obviously, those are just games. Yeah. These are serious games that we're applying this technology to. So there is a level of, there probably will be a departure in certain areas that's going to require our domain expertise, for certain, parts of the simulation to make sure that we get the simulation to a fidelity to which that, it's verifiable and is going to reflect real world outcomes. So it's a balance. We want to take the best and increase speed, velocity, and fidelity, but then also bring in our own capabilities from on the government side that we can leverage within this environment as well. So that's.
Yeah, and I can build on that a little bit. You're absolutely right. The gaming industry has done an amazing job. They have billions of dollars of investment in these engines. That's what we're starting with. We are working with a lot of the gaming industry tooling, and we're focusing on the discriminators and the gaps that Mike mentioned. A good example that comes up quite a bit, and if you live in the modeling and sim world, you'll understand it quite well. These games are focused on a certain experience, but we do have to make it realer. And one of the classic examples is material coding of data inside the simulation. So typically, games care if it looks pretty. Well, we also care what you're looking at. A great example is it dirt? Is it metal? How hot is that metal? All of those things matter a lot when you're creating sensors, which Lockheed Martin obviously cares about, and the AI also has to be aware what that material is because you're training the AI against that material. So that's something that we add to a lot of these gaming engines, and then it makes it more real. It makes it more accurate. Another great example is games can sometimes run at certain different frame rates. We need certain things to run at real time because when we hook it up to a real system, that system is built operating with a real world assumption that time is time. So we have to do a lot of that piping and tooling to make sure those game engines respect that, and when we do sim to real type things, that it's functional. And both those instances are something that we have a ton of experience on, we have a ton of, again, libraries on, and we can pull those in and then just focus on the discriminators and let the Lockheed Martin AI Center kind of add their AI components in it. And we've gone a lot more affordable, and we've gone a lot faster than we ever could before.
Yeah, I'm going to ad-lib here a little bit as chief engineer. Clearly, a video game doesn't have to bound risk. We have to bound risk of outcomes because our customer needs to know the art of the possible or something that should really not be possible that might be part of the scenario. So tell me how you do the risk management in this situation, ascertain that in the environment.
Yeah, I think it's going to be very use case dependent personally. Certain things are high risk, certain things aren't. So I don't want to paint with like a single brush on that question, right? So if it's let's say a live battle, there's a certain type of extra oversight you'll have over the tooling and how you integrate that. But the real kind of story comes down to the data you're putting into a lot of these. Mm-hmm. So when you're putting in the data, you're reading the interfaces, it's still going to come down almost getting into what Craig said earlier. The human's still going to make the decision for a lot of the risk-based assessments when you're building these out and you're using these tools. But the cool part is we also have a lot of the source code. We have actually all of the source code. So we kind of own that responsibility to build it for those specific defense requirements, be it risk or not. we own all of that tech stack to make sure we're managing it accordingly. So
That's
it's still our problem to solve.
Okay, we're going to move a little bit to interoperability and the importance of that. So interoperability, think between domains, think battle spaces, think systems. Why is that important, and why is your simulation environment uniquely equipped to help with that?
Like you said,
Yeah.
interoperability is huge. If you don't have interoperable systems, there's fragmented systems, data is incompatible, possible security concerns as well, especially when, kind of speaking about Fight Club, we have, methods and approaches to take agents and models from non-Lockheed Martin companies or teams and, integrate them rapidly into our simulation environments. And so we have a series of products that under the moniker we call star.os. It has an acronym, but it's not really, it's not really pertinent to this because Perl is a lot nicer. But it's a series of tools and frameworks to really kind of help accelerate integration, interoperability, both on tactical systems, which we've had, several demonstrations earlier this year, but then obviously within simulation and visualization. Two quick, pieces of information on that. One is star.sdk. And, as you can understand, it's a, service development kit. Tools to really just kind of be able to rapidly create AI services and to make it easier on the developers. The one that's really pertinent here is star.io, and it's, it's a framework. It's a framework to accelerate interoperability, as I was just saying, with, either tactical systems or simulations, and we've proven it out, not only with what we're doing on AI Fight Club, where we have that critical abstraction layer to be able to rapidly integrate both Lockheed Martin and other companies' models. But in addition to that, I think what's really important is we architected to be, GRA compliant, so government reference architecture compliant, and have proven out the ability to rapidly integrate with the joint simulation environment too. And so as, Mike had referenced Secretary Hegseth's comments, it is critical for industry to be able to work together to bring their various models and environments together, but also be compliant to very important reference architectures and in the joint simulation environment as well. So we're really excited about how we're proving that out with AI Fight Club for Perl, and it's something that is obviously going to be difference making both for us and what we're working on, but then being able to create that collaborative environment.
That's awesome. So in the aircraft world, we model and simulate many elements of the aircraft performance. We have labs, we have ground testing, but ultimately we find stuff when we fly, it slips through. So tell me a little bit, Adam, about what we're doing to ensure that this environment that you're creating creates a safe space once these capabilities go operational.
Yeah, and that leads kind of back to the risk-based assessment question almost. Dan kind of hit on kind of one of the ways we'll get to that answer is we are using a lot of the government reference architectures. We're not creating something new from an interface side with this tool, right? We are trying to keep it one-to-one as possible. So all the interfaces are the same, all the sims and the AI agents shouldn't even know they're flying potentially in a simulator. You got to reduce a lot of those simisms though, right? Because then the sims, even doing modeling in sim, you always have like, oh, on a simulator, you just click that button and it does it right, don't worry about that. A lot of those have to be eliminated. But the way we make sure it's ready and good enough is one, by going fast and using what we already have built, but it is going to be that iterative process as well. So, a good example is this is a tool to reduce a lot of that risk and a lot of those issues before it ever gets fielded. When we were training the 4v4 agents, month one, they were just slamming themselves into the ground, right? And that's what you expected, right? So, but then we met up again, it got a little bit better, and they started flying right, and we're like, wow. And it was almost watching a toddler grow and walk, and it was like, this is weirdly cool. Like, and then we started joking, all right, let's bet on who's gonna win this time. If we put, last month versus this month, do we win 100% of the time? So it's more about that. You're not gonna be perfect out of the gate with your first AI agent. You need to be comfortable when you're developing these tools that it's good enough now to put it in the real world. Right now, without this type of tooling, you are building an AI agent and hoping it works right. That's not going to work for our customer. That's not going to work for society. This at least is going to build you a degree of accuracy and belief that when you deploy it, it's going to work as it would expect. You know, even simple things like a jet flying. You've trained your AI agent 100% off every variable you had access to. What about when the bird flies in front of it the first time? Did your model train against that? What happens? Does it try to duck it? Does it try to fly above it? What happens? A lot of that we want to see in experiments, and it's kind of a trivial example, and you could argue, oh, your AI agent probably would be trained for something flying. I get all that, but then what about when you're talking about a bunch of different other variables that you've never experienced before until you deployed it? So this isn't the single answer to that, but it's a step making it better. So I always get nervous with AI holding out for perfect. When you hold out for perfect, even with something like ChatGPT, and it writes you, say, 90% of it right, and that 10%'s wrong, should you have not done that in the first place? No, of course you should have done that. It still saved you an inordinate amount of time. That's the same concept here. It doesn't have to be perfect to reduce your risk magnitudes. But you don't want to say, oh, well, we didn't 100% get everything validated and verified. It's not usable then, right? It's just a step in the right direction, be it a major one.
Yeah, it's like just the software testing.
Yep, exactly.
You're never going to get 100%.
Yep.
Mike, I'm going to ask you about this. So where do you see Pearl and AI Fight Club in the greater scope of Lockheed Martin artificial intelligence strategy? How does this fit in?
Yeah, going back to, we're developing a lot of artificial intelligence across the company. I mentioned the 20,000 assistants that we have. We have over 12,000 engineers using our AI ML operations platform to develop novel capabilities. But what we don't want to have is get stuck into the kind of trough of, pilot mode and, fielding these systems. I view that this type of technology is going to be absolutely critical and essential to get those technologies from pilot phase into operations. And through that, we have to build environments like this, test it, validate it, and we have to prove to our customers that this is acceptable as well. And we're managing risk to be able to forward deploy these capabilities moving forward. So I think that's really kind of the main push that I see from a simulation perspective. I will also mention, having been in this industry for a long time, obviously simulation is involved in it, but we do a lot of validation via flight tests. If we can get this environment to be at a level of sophistication and fidelity to where it's highly accurate, I would love to see a future that, this environment, we're doing the majority of the testing on it, and then we're just using the live flight test to validate the simulation versus the other way around, which is currently how we do things.
No, I think it's an excellent point, Mike. And it was something that really kind of triggered a thought here is as you take from simulation to the live flight or bring it into the platforms and sensors themselves, really kind of having to take the agent and the model and almost kind of like recode it into the into the system it's cumbersome. It can be cumbersome. And so being able to architect the model with something like what we're doing with Star.os allows you to kind of rapidly run it through the simulation and then almost kind of lift and shift into what would be utilizing on the test platform as well. And so I think what we're looking at here is really trying to leverage the best of the best is what you can do in simulation for the model, for the capability to improve it, and then as rapidly as possible get it on platform into a real environment and test it.
Yeah, and we're doing that in our software development world already, migrating on desktop simulations before we even get to the lab, and really cutting down the work that we have in the lab. So audience, be putting in your questions because we're going to have time for that in a little bit. But there's a couple more I have. Dan, we started out with national security use cases. What's next? What are you excited about for the AI Fight Club?
You triggered me right now because I'm very, very excited about this. So we have the national security use cases. We've talked a lot about the 4v4 kind of battle scenario in an aerial domain, but when we thought about AI Fight Club and when it was announced last year, the breadth of use cases are pretty tremendous. And so obviously a national initiative around Golden Dome for America, you really can kind of start to utilize the same foundations of agents collaborating with each other, but across multiple domains within those specific kind of missile defense types of scenarios. But then from there, you can get into non-defense scenarios. And so we have pretty heavy initiative that has been championed by our CEO, Jim Takelet, around wildland firefighting. And wildland firefighting is very nice proxy, if you will, to what we encounter in the mission in the defense space. And so you have satellite sensors that are trying to identify or detect whether a fire starts or what's going on with a fire. But then the ground vehicles, the Firehawks, all of the different collaboration that's occurring to battle the fight in and of itself.
Which is multi-domain, right?
It's multi-domain. It's multi-domain, and there you go. And the data available is, there's a ton of data available, basically, that is both, public and open data, and then some that we have access to from some of our platforms as well. And so when you bring all of that data together, it just allows you to expand and build very strong models. But in addition to that, there is a very heavy kind of research area that we can grow into. There's a ton of research going on at the innovation level, especially in the wildland fire space. And when you look at being able to take techniques like hierarchical multi-agent reinforcement learning, which is to not only bring in agents collaborating with each other, but then a command structure and how that dynamic works, a ton of work that's being done in that space as well. And so, as I said kind of at the beginning, we're looking to not only expand to non-defense oriented use cases, but then how can we incorporate the best of innovation? And so multiple types of AI Fight Club events. We have our 4v4 event that we're planning right now, looking to collaborate with industry partners, other companies, but then looking at how can we plan and execute a university-style event. We've had an excellent amount of outreach from the university community ever since we announced AI Fight Club. And so it's a really good opportunity where, kind of I'm talking to my team and I'm working with my team to say, all right, how can we build scenarios? How can we work out where we're actually working very closely with university researchers to, drive the pointy end of the spear forward?
Yeah, I love that, particularly with university research. I think targeting and focusing that is so critical for the nation. So I'm glad we're offering an opportunity for that to happen.
Well, if anyone in the crowd has any ideas for other scenarios or other ways in which we can use our platforms, use the simulation environment, please come and approach us or go to the website. It's very broad and it's meant to be very open.
Yeah. Okay, this is my last question, and so I'll give it to you guys after this question. Mike, looking ahead, I think maybe 5 years from now, how do you expect this advanced simulation and the initiatives associated with AI Fight Club and Pearl to change how AI systems are developed, tested, and used in national security?
Yeah, it's a great question. I hope that through the initial investment and development and success that we're having now, we continue to build upon that, build higher and higher fidelity simulations, different use cases, and ultimately prove to our customers that this is a valid way to test and validate requirements. I would love to see like the Pearl infrastructure, through our Astros AI, a commercial subsidiary, have this environment to which we can have as a service for our customers, other DIB members to validate their requirements. I hope that, if it's, in this environment, or I'm sure there'll be others as well that the government will rely upon, that we can use, these capabilities and it be required by the government, to test and validate via simulation like this. I don't think we'll be able to realize the vision of CJADC2 and AI integration into that without environments like this. So that's the hope, that it becomes a cornerstone of how we test and evaluate our systems across the board, across the DoW.
And go ahead, Adam. I don't know if you were going to.
You know, what I would share from you know, the 5-year prediction of the future, one of the things that maybe is hard with the way it's branded is AI Fight Club seems to be us versus somebody, right? That's not at all what's happening. I can share in the next 5 years, we're going to use this tooling and these events to build partnerships. And we're already seeing pieces in conversations we're having of people that want to participate saying, I don't necessarily have this piece, but I have this piece. And we're like, okay, that's cool. We can shift the design of the experiment in that direction to include you. So I really look forward to using this to build a Rolodex of AI-enabled companies that we have, I wouldn't say pseudo-validated, but validated to some level to say, well, when we're approaching and attacking something like Golden Dome, you're gonna take care of this, you're gonna take care of this, we validated in this environment, you know how to integrate with us, you're in our systems, all of that's gonna come really real, really quick, and that way when RFPs come out or the next OTA drops, we're not sitting saying, hey, let's build the team now. We already have a massive team ready to attack whatever problem that comes up.
You stole my comment.
Sorry.
No, that's okay. You said it much more articulately than I would.
I don't know.
But that's it. I think what we see is not even just 5 years down the road, it's right in front of us. We're being challenged by our customers to move faster, to be able to develop faster, to be able to get our solutions and our platforms to the warfighter faster. And the only way that that's going to happen is through collaboration, bringing the entire industry together. That is the vision of what we're looking for AI Fight Club, an open environment that encourages and really kind of it incentivizes collaboration across industry and academia, as we've said. That's right in front of us. It's going to be something that carries us for the next 5 years as we encounter more challenges, especially as the customer provides even kind of more expectations from us and from industry. And so, you know, that's really the vision. It is right in front of us. It is something that's going to drive us for the next 5 years plus. But we are putting the challenge out here not only to ourselves. I'm challenging my team, Mike's challenging us, but we want to put that challenge out to our competitors, our competimates, our friends, to join us and to work together and actually driving this forward, advancing simulation visualization, advancing the more complex AI models, and then develop solutions for the warfighters as well.
And from the nerdy engineering standpoint too, that I love more than anything, you know, from just like a technology standpoint, I want this deployed anywhere, anytime. I want it fully immersive. I want you, when you see the AI doing something, to tell the AI naturally, don't do that or change that. You know, for the firefighting one, draw a new fire line in this virtual environment and see the AI adopt and respond and see what the fire does differently and partner with, you know, agents. There's a whole bunch of cool tech being built by this that we need, you know, this group in the audience to help us build. And that's probably the coolest part, is think about experiencing this AI in real time, fully immersed, and then modifying it and picking the best of the best and putting it all together. That's what we want Fight Club to be from a technology standpoint at the end.
So since you went down the nerd path,
me.
That's okay, because I love it too. You know, you hear Jensen Huang talk about physical AI. And really kind of utilizing simulation to bring all of the work that we're doing in the scenarios that we're going through in the simulation environment to the physical world. Again, the promise of what we're building out here with Pearl is XR. Mike mentioned the work that we're doing with Meta, being able to hopefully bridge the two together, where we have the user interacting with the real world through the simulation environment. Like I said, he went down the nerd path. That's something that I think we have a future focus on. We are working, with the right commercial partners, and it's something that, again, Pearl can really bring the power of what we're doing to the communities and to Lockheed.
Yeah, I think it's so important that the message be that this is friends helping friends learn to fight together.
Yes.
It's a partnership, not an adversarial thing. So remember that when you hear the name. So I'm going to ask the first question, and you touched on it, and by the way, it's free for all, so whoever wants to answer can. But tell us a little bit more about the reception of AI Fight Club with industry, Department of War, and academia. What have we seen so far?
I think
You were pointing to me?
I'm
Okay, I
pointing
thought you were
to
going to take it,
No,
but
you
that's
take
okay.
it. You take it. I'll talk about it.
Just a lot of really great outreach, a lot of energy, a lot of interest in what we're doing with AI Fight Club. And so, we have some partners that we're working with right now as we're driving towards our first event. As I said earlier, the university outreach has been amazing. I think we've been, using the firefighting example, just kind of a fire hose of energy and excitement from the university community. And I think what is also, in addition to that, to kind of build off of what Adam was saying, is that we're having, I'll call them non-traditionals, approach us as well. They're saying, I'm not building an AI agent to do 4v4 aerial combat, but we bring this capability. And we're answering them. We're saying, okay, this is awesome. Bring it in. You have a simulation capability or an environment. Cool. Let's take another agent that someone else is working on and bring them together, and we still learn about what that full tech stack can do, and then it opens up more opportunities for partnership.
And then does it become included in the library of capabilities you have? That's part of the deal.
Absolutely.
Yeah.
And it also, just to kind of talk about StarOS again, the interoperability layer, we continue to be able to prove out that capability, because as we bring in more partners, be able to work within our systems, be able to hit the same interfaces that we are, and it allows for us to actually be able to prove out that capability and proliferate that amongst the industry as well.
Okay. All right, this is a hard question, and it's one of the most popular. How do you handle the complexity of modeling realistic adversarial scenarios while keeping the computations feasible? And I mean, that's always the problem, right? And the more stuff you have and all the terabyte weight that comes with that. So.
Yeah, I could probably take that one. So where we have a lot of experience is we've already had to do that to train 5th-gen pilots. There's a lot of SAFs, semi-automated forces, and other tooling that we've had to do to make sure those adversaries act as you would expect when our pilots are flying against them.
Yeah.
That's kind of what I'm referencing. That's a clear Lockheed discriminator at how we can pull this off so quickly, is we're leveraging that same technology and pulling it into Fight Club. So that's how we're solving it. The point is still extremely valid, though. There is a lot of effort, there is a lot of complexities, there's a lot of compute that's required. Part of the Pearl system is to understand how to containerize and spin those up and spin those down based on the use case. So for instance, when you're training an AI agent, you're definitely almost always running faster than real time. You're doing millions of calculations a second. You're heavily on a GPU. You spin them up or down accordingly, but you're not necessarily running that full synthetic, high quality, subsystem of a 5th-gen fighter. You're going off of typically some other data. You have to combine those agents together and then run it in the Fight Club environment. So the Fight Club environment likely will, in many instances, always be real time. It's very, very high fidelity. You have to spin up and down GPU compute. Fortunately, the gaming industry has done a lot of really good stuff there to allow us to use the hardware we need to use and parallelize a lot of the capabilities. But that's always going to be a fundamental problem, and then that goes back to what use case are we doing for this specific Pearl system? Are we doing operations analysis? Well, if you're doing that, your Fight Club environment's maybe a few different puzzle pieces than it would be if you're doing a force-on-force engagement. And what I mean by that is the operation analysis side doesn't necessarily care when they're validating it that every subsystem of whatever you're using is correct and the oil pressure is right. That's probably not relevant. That's probably a waste of compute. But if you're doing a dogfight, that might be relevant. And if anything, you should be training against that data so you're not getting any surprises at the end of the day. So the simple answer is that's a fundamental problem. But we do have the architecture to scale it up and down, and then we have the models and data behind the scenes to get it good enough for a lot of our current defense use cases. But we're going to build this library as we go on. This isn't a one-and-done solution, but we're going to be ready for each of those problems as they come up.
I mean, things like multi-fidelity optimization that we're doing in CFD and other areas, I guess they can be utilized.
Right. That probably isn't needed by OA. Yeah.
We don't need it here, but we need it here, and then you can
Yes.
tune it to what you.
And that's the interoperability story a little bit, but that's even more of our architecture, how it's composable, how it's using to simplify, it's a plug-in architecture where you pick the pieces you need, you plug them in, and that's the new Fight Club environment. We mentioned 4v4, we mentioned firefighting, we mentioned Golden Dome a little bit. All of those have slightly different content you're putting in and slightly different simulations you're putting in, just to mainly make sure you can do the compute in an effective way without wasting your time.
I understand.
And just to mention, on the hardware infrastructure side, to quote, was it the movie The Right Stuff, no bucks, no Buck Rogers. You're not going to be able to do the technology unless you invest. And we've invested, significantly within Lockheed on infrastructure through the Asterisk AI for Government partnership that we have. I mentioned Meta, mentioned NVIDIA, but also Oracle is a big partner on that. So we're investing, partnered with Oracle and their Oracle Cloud Infrastructure, to which we can host, GPU workloads on unclassed networks, classified networks, and to be able to expand. So we can, as Adam was saying, we can rapidly spin up and spin down, and we'll have that infrastructure available so we can do this right.
And the fidelity is a core piece of the research we're doing as well. What fidelity and what data is needed for what level of AI agent isn't a super simple question to answer, but that is where Lockheed's investment is going to research to say, when is it good enough for what type of AI agent? We feel like we're making pretty good progress there, and we'll have some more answers shortly.
That's great. And thank you for your questions, audience. Really good questions here. So can one of you describe the day in the life of an AI Fight Club event?
Go for it, Dan.
You want me to go for it?
I do.
So we've actually, so we've done a couple of dry runs for our first event. We're hosting it down at our Center for Innovation, or we call it the Lighthouse, in Suffolk, Virginia, and we have a really nice setup, to be honest with you. The Adams team and our colleagues in our aeronautics division have both the what we call the JADO world, kind of a top-down view. We have our 3D visualization environment, so utilizing UE5, you're actually in the cockpit of the F-16, being able to see what it's seeing, showing what the what kind of actions it's taking. If it shoots off a missile, you see it on the screen, and kind of be able to observe and see the kills in real time as well. And then obviously we have a scoreboard that really just kind of shows the status. If you look at kind of the scenario or the design of experiments for what we're looking at for this scenario, there's there's an envelope of performance. There's a home base on one side, a home base on the other, fuel, and the teams need to be able to engage with each other. If if one of the agents exceeds the envelope, whether through the hard deck or too high or outside of the box, then it's considered a kill. And so in addition to that, the plane has to be able to perform its job and then make it back to base with bingo fuel. So there has to be enough fuel left over. And so all of these are different parameters that are explored in the design of experiments. And so that's a quick kind of like visual description of kind of what you see and how it works. But really what we want to do is a nice little kind of a conference space. If you think about it, almost as big as this, big screens up on the, up on the stage, like the one we're behind us, and they have different stations. Okay, so we run through a couple of scenarios, do a couple of Monte Carlo analyses, be able to analyze it, see how it works, and then go through a real-time analysis as well, score everything, and collaborate across our teams, across the different competitors in the teams as well, to be able to say, okay, our agent performed well in this area, it didn't perform well in that area, they flew around in circles and just ran away, and so what can we do to retrain our models? What are the parameters that we're going to be able to update and adjust to be able to see how that we can kind of mutually improve. As much as we want to put kind of the challenge out there for all of our partners and mates to be able to kind of put a trophy up next to everyone, and then kind of take a picture and be able to broadcast that Lockheed Martin is the best at 4v4, and we've won AI Fight Club. But the reality of the fact is we want everyone to be a winner, and especially kind of the community and our customer. And so it's a great opportunity to collaborate, as we've said a few times.
Yeah, it's super exciting. Mike, I wanted to touch on something that I just thought of it, and maybe it's a stupid thing to talk about, but we recently flew the X-59, and I was thinking about, in the future, the long-term vision, thinking about control room training and being in scenarios that are much more rich than we've been able to provide folks, and exercising teams to be prepared. And that would be the same. I mean, it's going to enhance training as well. It's a great opportunity. So this, I think, is an easy question, but are university student teams invited to participate at AI Fight Club?
We've talked about that a little bit. We're still kind of getting our organization around the university events. There are some restrictions just to the way that the Fight Club is structured related to some potentially export information and things like that. So it's not a blanket yes, but it is a yes. We're going to share a lot of information in the next couple months. We're probably going to be doing it more like almost like a hackathon to start it, to where we're going to introduce the university students and however those teams are structured, and then they're going to come participate and add some nuggets to the Fight Club experience. Now with that, that's probably the start. That's not necessarily where it ends. There's just a lot of logistics that need to be worked out for that. In the future, absolutely. You know, you mentioned kind of the day in the life of a little bit. It is a little bit inspired by kind of esports. It is supposed to be fun. It's supposed to be loud. It's supposed to be a competition. So I do see the universities getting really latched on to that. There's a lot of similar examples where universities compete against each other in coding and other environments. We absolutely could see this branching to that. In the immediate term, though, we want to get the universities kind of signed up and engaged in a hackathon-y type environment. And then from there, build those teams. It's kind of like almost an expansion draft in sports. We got to build those teams so they can compete on the field. We don't have all those teams in the arena built yet for universities, but it's in work, and we'll have a lot more information shortly.
And we've really talked about, I mean, think about the diverse areas of research that you get from a lot of these university teams. One that obviously I'm pretty familiar with is, kind of trust, trustworthiness, verification. How do we learn from them? And it just provides an awesome opportunity to, learn from the depth of knowledge that some of these university teams are going to be able to bring to this event, this hackathon, and it would just, kind of have just more of a broad impact to each of the areas that we're looking to address overall with modeling and simulation and the benefit that it provides.
Yeah.
Yeah, because I mean, the key piece is, we want the universities involved. It is very important that we're making AI agents and content that can be deployed, and I think that's something we don't want to miss. This isn't necessarily just a fun science experiment. It is, but it has an absolute urgency for our government customer, and that's what we want to make sure we also focus on. So even with universities involved, we want to make sure it's still hitting that mission statement.
Sure, that makes sense. So this question was popular. What practices or lessons learned can you share with industry, with the audience, to mature their own AI strategy?
Yeah, that's a great question.
It's a hard one. That's why we gave it to you.
A little bit of our Lockheed journey. We've been doing artificial intelligence, machine learning for decades, but we really took a tops-down approach about 5 years ago, where we started this big bet. We set an overall AI strategy for the entire corporation. We knew that this technology was going to advance so fast that if we didn't do that, we'd have 50 different organizations in the corporation building the exact same thing. And then I'd spend, as the CDAO, the next 5 years trying to reverse everything out of the gears to get to one solution. So building out and getting conviction from a tops-down perspective was absolutely key. And then you have to invest, right? So you have to invest in a team that can act as a center of gravity for innovation to supply AI capabilities, technology, process for your entire organization, so there's consistency there, right? Mm-hmm. And you need to build out governance of the AI. That's a huge thing, right? So we have a lot, given the missions that we provide, we have a lot of governance on the data side, on the model side, to understand the overall lineage of how we develop the artificial intelligence, and when we make changes, what are those changes, and all that. But it comes down to ultimately building solutions that engender trust. They are doing things that we expect them to do. So having a formalized process and teams of folks with various perspectives to help weigh in on that is absolutely key. And I will mention, like with generative, a lot of AI discussion is around generative. We're using generative solutions within Perl or whatnot. It's a great capability to be able to gather lots of information, to consolidate it, to help speed up the simulation process. But generative solutions ultimately are going to make their way into the mission space, right? And the challenge there is typically in these spaces, up to this point, we've been dealing with very deterministic solutions. Even in the AI space, deep learning models, neural nets, whatever, we can get it down to a relatively deterministic type of evaluation of that. Generative is non-deterministic. So we need to figure out, and this hasn't been really solved yet, but how do you look at generative AI solutions and having that integrated within your system to be able to understand what the risk profile is, the boundaries, and ultimately, what is the level of acceptable risk that you're willing to take? You're never going to be 100% sure. Right? We'd like to be 100% sure, or 9 decimal places sure. So that's an area that to keep an eye on, stay plugged into work that's being done within the government from a standards perspective. We have people that are supporting a multitude of standards bodies like NIST and others that are trying to drive out AI standards, to drive consistency, to drive the trustworthiness in what I would consider legacy AI type applications and the new world of generative AI that's coming out. So just stay connected, use industry best practices and government best practices, but know that this is something that we're figuring out real time. The pace at which AI is developing it's rip your face off fast. And to stay ahead or stay up to speed, you have to constantly be out there understanding what's going on, what's the latest state-of-the-art practice that we can employ within our process. So like for our overall data strategy, governance process completely mirrors the DOW's approach. We took that, and then that's where our starting point was. So it's really important to stay connected there.
Yeah, I'm going to address this question. Somebody had asked, several of you were interested in beyond modeling and simulation, how is LM utilizing AI to optimize performance and reduce risk in high energy systems such as F-35 and F-22? And you hit on it. Something like auto GCAS, auto ground collision and avoidance, has an element of autonomy that would use more deterministic methods. And we have those types of things on our aircraft now.
Absolutely.
We have not ventured into the more of the higher risk, unbounded scenarios on aircraft. We're using those tools to do our design work,
right.
but not necessarily riding on an airplane quite yet. So. We have 3 minutes. I guess there's one more question we can ask. Let's see. So what's next for AI Fight Club? How do you go from sim to real?
What's next is for AI Fight Club is to continue to kind of build out the scenarios that we're working on. I think we touched on a few very specific examples. We want to increase the breadth. We want to be able to increase the complexity and the fidelity that we're building out in our simulation environments, be able to incorporate new platforms, and then be able to kind of expand our collaboration with our partners, both in industry and academia. And so by virtue of really kind of being able to go from aerial combat through to Golden Dome, all the way to something like firefighting, and go back and forth between that, iteratively, is just going to be able to kind of expand the impact that we're having with AI Fight Club. In addition to that, with respect to Pearl, exploring the hardware. What kind of XR hardware can we incorporate? What is the operations analysis of which how we take the user and what just is the fundamental approach for how the user would interact with both the simulation and the real world. I think that's something that some folks who are much smarter than I am that work in our team are really diving into right now. And so increasing the breadth of the scenarios that we're working on, being able to find more and greater opportunities to collaborate with our partners, and then really dive forward into the innovation, into the research for how you bring simulation and visualization back to the real world as well.
Yeah, you can expand in all kinds of directions.
I'm just super excited about where it is that we can go. And I think that's one of the things that when we talk about AI Fight Club, it is really a proving ground. When we have our overarching strategy around simulation, visualization, and everything we can do from a training and a testing perspective for AI, Fight Club's that platform. It's that avenue for us to just bring everyone together, utilize it as that opportunity to kind of hold hands with our partners to bring forward what we need to do to help solve some of the nation's hardest problems.
That's awesome, Dan. Well, I want to thank you, gentlemen, and on behalf of AIAA, offer you these challenge coins.
Thank you.
Thank you so much for joining us today.
Thank you.
Totally enjoyed the conversation. Thanks, audience, for being here. And I think that's it for this session. So thank you very much.
At Lockheed Martin, we see things differently. We look for innovation and see how it can move the world. Because our mission means more than just protecting tomorrow. It's about propelling it forward. So we use the power of data to build powerful connections. Utilize AI to bring our technology to the fight. And look for answers in places others would never think of. Beyond what's possible, we go past that every day. Take a closer look at Lockheed Martin, and you'll find a team of innovators that see things from a different point of view. But our mission is always clear.